Dear students, in this video I explain state space representation using canonical variable. This method is also called as parallel programming method, and the matrix A obtained from this method is called as canonical form or normal form or fastest form. So this method is basically based on the partial fraction expression. That means the given transfer function T of S can be split as partial fractions. Then we can draw the programming, that is parallel programming. So consider the transfer function T of S is like this. Here numerator and denominator, and denominators are like this. And if case 1, so here m and n, m is nothing but highest s power in numerator, n is nothing but highest s power in denominator. Case 1 is considered as m less than n, numerator s power highest value is less than denominator s highest value. Then we can follow the case 1. How can you design state model by using the case 1? Now I will explain. Consider the transfer function T of S is equal to this format, that is C1 by S plus A1 plus C2 by S plus A2. This is partial fractions. So the given transfer function can be converted into a partial fractions like this, and draw the parallel programming for this method. The parallel programming is like this. So already we know. So how can you draw the state model for 1 by S plus A? Already we know how can you design 1 by S plus A format. So in the last videos, so 1 by S plus A programming consists of one integration, one summation, and one feedback block. So this arrangement is called as the programming for 1 by S plus A format. So here in this expression we have C1 by S plus A1. For that, this can be write in C1 into 1 by S plus A1. 1 by S plus A1 programming is like this: one summation, one integration, and one feedback. This part is nothing but the programming for 1 by S plus A1. So that this block is A1, and this block is multiplied with C1, so that C1 is connected in series with this one. Like this we can connect number of blocks in parallel. So this one is, so second one, C2 by S plus A2. How can you write this one? C2 into 1 by S plus A2. The 1 by S plus A2 programming is this one, and this one is multiplied with C2, so that we can connect the series C2 block. Like this we can connect the number of blocks. Here all the blocks are connected with the input U of S, and finally all the blocks are summing together and given as a output Y of S. So this is the format or parallel programming method. From this parallel programming method, directly we can write the A, B, C and D matrix. Otherwise we can write the equations for x1 dot of t, x2 dot of t, x3 dot of t, and so on, and output Y of t. Then we can collect the A matrix, B matrix, C and D matrix. Otherwise directly from this diagram we can collect, or we can write A, B, C, D matrix. So now we will see how can you write the A, B, C and D matrix directly from this diagram. So these are the matrix A, B, C, D. So A matrix, this is A1, here mistake is there, minus A1, 0, 0, remaining all are zeros, 0 minus A2, remaining all are zeros, and so on, 0, 0, 0, and so on, minus AN. So how can I write this A matrix from this diagram? So here this is negative feedback, so that this is minus A1, this is minus A2, and so on, minus AN, so that the matrix A can be write like this. Diagonally we can place that values, and remaining all values are zeros, so that A1 diagonally minus A2, minus A3, minus A4, and so on, minus AN. So like that we can collect the matrix A, or we can write the matrix A. And B matrix always a column matrix, that is always ones. So whatever it may be the given problem, the value is always ones. And C matrix is equal, already we know C matrix is the row matrix, and we can collect all the constant values, that is this value C1, C2, C and so C3 and so on Cn. These values are collected, then the matrix C is arranged C1, C2 and so on Cn, and D value is always 0. So this is the method to write the A, B, C and D matrix from this parallel programming method. So this is the case 1. Now we go for the case 2. If degree m is equal to n, that means highest s power in the numerator is equal to highest s power in the denominator, then we can go for the case 2. How can you collect? How can you design the state model from the case 2? So here transfer function T of s is equal to C naught plus sigma e is equal to 1 to n into Ci plus s minus a1. Only C naught element is added, remaining is same as the case 1. This total function is same as the case 1. Only the addition term is C naught. So that C naught is added, remaining all of the terms are same. So that the parallel programming diagram is like this. So first block same as the case 1 and so on, second block same as the case 1 and so on, nth block same as the case 1. Only the difference between the case 1 and the case 2 is C naught. Here C naught is additional term is added in case 2. If this is case 1, no need to add C naught. Only the C naught term is added here. This is the difference between case 1 and case 2. If m is greater than n, C naught is there. Sorry, C naught is not there. If m is equal to n, then C naught term is added here. Remaining is same as it is in the case 1. Only C naught is added. And now how can we write the A matrix, B matrix, C and D matrix? There is no difference in A matrix. There is no difference in B matrix. There is no difference in C matrix. Only the difference in D matrix. In case 1, D value is 0. In case 2, D value is nothing but C naught. Whatever the value in C naught block, in this block, that value is nothing but D. So this is the method, that is case 1 and case 2 in parallel programming method. Now consider the example problem. Obtain the state model by first transform or parallel programming method. Both are same, by using whose transfer function is s square plus 4 by s plus 1 into s plus 2 into s plus 3. Here the question asked in different ways. First transform or parallel programming method. Both are same. The given transfer function is this one, s power 2 plus 4 divided by s plus 1 into s plus 2 into s plus 4. The first step, we want to find out the partial fractions for the given transfer function. So that the given transfer function is s square plus 4 by s plus 1 into s plus 2 into s plus 3. Now apply the partial fractions. Already we know how can apply the partial fractions for this one. So a by s plus 1 plus b by s plus 2 plus c by s plus 3, and calculate a, b, c values and substitute this equation. We can get, so a value is 2.5 and b value is minus 8 and c value is 6.5. So that this transfer function can be arranged like this by using the partial fractions. Now we can draw the parallel programming. So already we know how can you write the parallel programming. Here 3 terms is there, so that 3 blocks are, three parallel blocks are a requirement. So that the diagram is like this. This one is one parallel programming, this one is second one, this one is third one. So that 3 parallel programming blocks are required. So the first block, so this is the format. So integration, summation and one feedback block. How can you fill this block and this block? Here the block, so this one s plus 1. So here s plus a1, in the sense this block is filled with a1. Here s plus 1, so that this block filled with 1. This is the negative feedback, already we know. And this value is c1. So this one is nothing but c1. Here the c1 is nothing but 2.5. So that the first block is right like this. So summation, integration, and this black value is 1 and this black value is 2.5. How can you write the second one? Summation, integration and feedback block value is 2, and so forward path multiplied with 8, so this is C2. So and here the minus value is there, so that the second blocks are like this. So format is same, summation, integration and feedback, and C2 multiplied with this block. So here C2 is nothing but minus 8, so that 8 multiplied, and here the value is negative because this value is minus. Otherwise we can place plus here, we can put minus here, that is also same. Otherwise we can write 8 here and we can place the sign minus sign here, that is also correct. So that second parallel programming is completed. Next, third part. So the function is this one, 6.5 divided by s plus 3. How can you write 6.5 divided into 1 by s plus 3? So here the feedback block value with 3 and the series multiplied with 6.5, so that feedback block multiplied filled with 3, and so this function multiplied with 6.5. So this is the parallel programming diagram. Directly from this diagram we can draw a, b, c and d matrix. Otherwise we can write the equations for x1 dot of t, x2 dot of t, x3 dot of t and output y of t. Then we can draw the matrix a, b, c, d matrix. So directly how can you draw the a, b, c, d matrix are shown in previous methods. So that is the, the basic method. So now by using that method, so I will write a, b, c and d matrix. A matrix minus 1, 0, 0, 0, minus 2, 0, 0, 0, minus 3, that is A matrix. And B matrix is column matrix, only 3 blocks here, the 3 parallel blocks is there, so that A1, sorry, 1, 1, 1. And C matrix, here only 3 blocks is there. C matrix is nothing but row matrix. First value is 2.5, second value is 8, third value is 6.5. So here minus is there, so that first value plus, second value minus, third value is plus. So the C matrix is 2.5, minus here minus is there, so that minus 8 plus 6.5. C matrix completed, and D is 0. By writing the equations, the same answers we will get. Now we will see by writing these equations, so the same answers will get or not. So the first equation, x1 dot of t. Here x1 dot of t is nothing but this summation output is nothing but x1 dot of t. So what are the two inputs for this summation? One input is u of t and the second input is x1 multiplied with minus 1, because this is the negative sign, negative feedback. So that x1 dot of t is equal to u of t minus x1 of t, and x2 dot of t is equal to this summation output is x2 dot of t, and this summation having the two inputs. One input is u of t, second input, this is negative feedback, so that minus 2 multiplied with x2. Therefore x2 dot of t is equal to u of t minus 2 into x2 of t, and x3 dot of t is equal to u of t minus 3 into x3 of t. So and finally output y of t is equal to 2.5 multiplied with x1 and minus 8 multiplied with x2 of t and 6.5 multiplied with x3 of t. Therefore final output y of t is equal to 2.5 into x1 of t minus 8 into x2 of t plus 6.5 into x3 of t. So these are the equations, x1 dot of t, x2 dot of t, x3 dot of t and output y of t. From these equations we can write the state model, that is A, B, C, D matrix. So the A matrix is nothing but minus 1, 0, 0, because x1 dot of t is having only x1 of t, there is no x2 of t, x3 of t, so that minus 1, 0, 0, and the input u of t is there, so that b value is 1. Like that we can write A, B, C and D matrix. So already we discussed the direct method, the same answers will be there here. So A value, A matrix is minus 1, 0, 0, 0, minus 2, 0, 0, 0, minus 3, and B is 1, 1, 1, and C is 2.5, minus 8, 6.5, D is equal to